circular cone and the ratio 4 to 3, and its volume is 2156 centimeter cube. Find the cone surface area and the total surface area of the cone. So we have this. We have a cone like this. The surface area is the area of this cone section. The total surface area is the area of this base plus the area of the base. Now let's work this out. We are told that the ratio. Okay, let's start from the volume. Volume is equal to 1 over 3 pi r square height. And we are told that is equal to 2156 centimeters. We are also told that the ratio of the height to the radius. The radius and height of the right circular cone are in the ratio 4 to 3. That is r over h is equal to 4 over 3. R over h is 4 over 3. So what does that imply? It implies that h equals to 3 over 4 r. Therefore, 2156 will be equal to 1 over 3 pi times r squared times 3 over 4 r. So then you cancel this. So it means that 2156 divided by pi times 4 is equal to r cubed. So I can just let it plug in 22 over 7 for 5. So I have 2156 times 4 times 7 over 22 equals r. So r is equal to cube root of 2156 times 4 times 7 divided by 22. Let's find what r is. So r is equal to 14 centimeters. Now, surface area. The core surface area is pi rl. Total surface area is equal to pi rl plus pi r squared. And if I factorize that, it's going to be pi r into l plus r. And we have that slant. We are going to find the slant height now. What is L? Because surface area is pi r L. Here L is the slant height. Total surface area is pi r L plus pi r squared. That is the surface. When we have it like this, the area of this is the curved surface. The total surface area is the sum of the surface area here plus the one below like this. Now let us find this L. We will find it like this. We know that our R now is 14 cm. Our H, we have gotten the relationship here that H is equal to 3 over 4 R, which is equal to, by the time we calculate, it's going to give us 10.5 centimeters. Now, to find L, we use Pythagoras theorem. So L is equal to square root of 14 squared plus 10.5 squared. Let me use the calculator together. So this one gives me 17.5. So this is 17.5 cm. So L is 17.5 cm. So core surface area pi RL, and that is giving pi times 14 times 17.5. So that gives me 769.7 centimeters squared. Now total surface area is equal to CSA plus pi r squared, and that's giving 769.7 plus pi times 14 squared. That's the way. So that's how you get it. 1385.4 cm squared. Oh. Okay. There is a right circular cone of height h and vertical angle 60 degrees. A sphere, when placed inside the cone, it touches the curved surface and the base of the cone. The volume of the sphere is, we have to find the volume of that sphere. So we are going to have, we have a cone like this. And there is a ball inside the sphere. And we are told that this angle here is 60 degrees. since it is right circular, this one and this one will be equal. So we are going to add this place to the 60, and we are going to add this place to the 60. So we are now asked to find the volume of the sphere. The basic thing to find here is to find the radius. We are told that the height is h. Now, we have this. This is r, and this one too is r, and we have this. So if I bisect this place will be 30 degrees, and this place will be 30 degrees. And you know this is h. This place will be 30 degrees here. This place will be h minus r, and this place will be r. This is r. We're looking for a triangle. Now, if you look at this, this is the hypotenuse. This is the opposite. It's facing this angle here. So r over h minus r is equal to sine 30 degrees. This one over this one is equal to sine 30 degrees. So we have, and this is half. Therefore, 2r is equal to h minus r. So h equals 3r. Therefore, r equals to h over 3. So since you have gotten the r now, we can now find the volume of the sphere. So volume of sphere will be equal to 4 over 3 times 5 times h over 3 cubed. And that's going to give 4 pi h over 81 centimeter cube. Okay. If a solid right circular cone of height 24 centimeter and base radius 6 centimeter is melted and recast in the shape of a sphere, the radius of the sphere is this. It's dash. They're asking us for the radius of the sphere. Now, this is conversion of volume to volume. That is, the volume of the sphere that we are going to get should be the volume of the cone. Now, what is the volume of the cone? Of cone is equal to 4 over 3 and 1 over 3 pi r square height. What is our r? We are told the radius is 6 centimeters. Height is 24 centimeters. So volume of cone will be equal to 1 over 3 pi times 6 squared times 24 cm. Now, volume of the sphere that you are trying to get will be equal to 4 over 3 pi r cubed. Where r is the radius of sphere. And the volume of this cone must be equal to the volume of this sphere. Therefore, 1 over 3 pi times 6 squared times 24 must be equal to 4 over 3 pi r cubed. Now let's cut. All here is 6. So pi cancels pi. Therefore, 6 cubed is equal to r cubed. So r will be equal to 6 centimeters. Therefore, the radius of the sphere will be equal to 6 centimeters. So the new sphere formed, its radius will be equal to 6 centimeters. Okay, two spheres of radius 6 centimeters and 1 centimeter are inscribed inside a right circular cone. The bigger sphere touches the smaller sphere and also the base of the cone. What is the height of the cone? So we have a picture like this. So we have a bigger cone and we have a smaller cone. And we are told that the radius for the bigger one is 6 and the radius for the smaller one is 1. So we are now asked to find the height of this cone. Now, we can can try to bring up certain similar triangles. This is the way I do it. Let's take the distance from this point to this point. Let's call it x. From the apex to the top of the smaller sphere. Now, from this place to this place now will be x plus 1. From this place to this place will be x plus 2. From this place to this place will now be x plus 2 plus 6. So this place will be x plus 8 centimeters. From this place to this place. Now let me try to bring out two similar triangles. From this one, you can see this place and this place. So we have similar triangles. This. That is x plus 1 over 1 will be equal to x plus 8 over 6. Okay. The base in this triangle here is 1. The base here is 6. So let's work it out. So we can now say that 6x plus 6 is equal to x plus 8. So 5x is equal to 2. X equals 2 over 5, which is equal to 0.4 centimeters. Okay, let me leave it as this. This. Now, if you look at it, the height of the cone will be equal to x plus 2. That is the diameter of the smaller sphere plus 12, the diameter of the bigger sphere. Can you see? And that is going to be 0.4 plus 14, which is 14.4 cm. Or I can say 2 over 5 plus 14, which is equal to 14 2 over 5. 22 over 5 centimeters. Very easy. You can look at it from that perspective. Another way is you can consider these two like this and this. You know that the ratio of this place to this place will be 6 to 1. So let's call this one 6t. And let's call this one 1t. Considering the ratio of triangles. Now, you can now say that x plus 2 over 1t, over t. This place. Because this is 1. And this one will be bigger than 1. So it is 1t. This place is 6. This place is 60. Because the ratio is the same. Is equal to x plus. This is x plus 2. X plus 14 over 60. Now let's cancel t. T cancels t. So I can now say that 6x plus 12 is equal to x plus 14. So I can now say 5x is equal to 2. X equals to 2 over 5. And from there, we can calculate the total height again. So, in these two ways, we have realized that x can be easily gotten to be 2 over 5. In the diagram, two spheres are squeezed inside a cone, with the bigger sphere touching the base of the cone and the smaller sphere. The dimension of the cone is as shown in the diagram. Find A, height h, and volume of the cone. B, radii, Ra and Rb. So this is Ra, and this is Rb. Volume of the spheres, that is, volume of this one and this one. Ratio of the volume of remaining space to the volume of the cone. They want us to find the volume of this place and compare it to the volume of the cone. Now, we have seen the dimension of the cone. The base has diameter of 24 centimeters. And it has length height of 37 centimeters. So let's start. A. We have something like this. And this one is 24. So from this place to this place will be 12. And we know that the slant height here is 37 centimeters. So you can see. So to find h, we use Pythagoras theorem. So h squared will be equal to 37 squared minus 12 squared. And that will be using the formula for difference of two squares. 37 minus 12. So what is this? This one is 49. And this one is 25. That's easy. So h will be square root of 49 times 25. found h, 35 centimeters. Now to find the volume of the cone, we are using the formula. Now that we have found h to be equal to 35 centimeters, volume of a cone is 1 over 3 pi r square height. What is, we have 1 over 3 pi. I will rather leave it in terms of pi. What is our r? 12. What is our h? 35. And that's going to be pi times 4 times 12 times 35. That will be equal to. So the volume of the cone is 1680 pi centimeter cube. I found it in terms of pi. So we have gotten the first part. A, h is 35 centimeter. Volume of the cone is 1680 pi centimeter cube. Now for the big part, we have to find the radii of the two spheres. And here we are going to use our knowledge of circle geometry. Here we have this. Let's do that of the lower sphere. Now, we have this to be 35. The height. And we know from this place to this place is 12. And with our knowledge of circle geometry, we know that if this place is 12, this place to this place is 12 because they are tangents to the circle. So this place will be 12. This place will be 12. That's the order. And you can consider using trigonometric ratio or just using comparison of sides. How do I mean? I can start thinking of taking the difference and some other properties of the circle, putting it to use, or using trigonometric ratio. I'll use the two here for this one now. Here, I have this one to be 12. Automatically, this one will be 12 from our knowledge of geometry, circle geometry. Because this is tangents. We know this place to be 37. So we should have this place to this place now. It will be 25. That's one. Now, to find the radius there, we have this one to be r, this one to be r. And since this one is tangent to it, this place is right angle, this place is right angle. So this place too is the right angle. So you can see that we're having some triangles there. Which means that from this place to this place now, we are going to have 35 minus r centimeter. 35 minus r centimeter. So this is a triangle. This place being the hypotenuse. And since this place is hypotenuse, we can apply Pythagoras theorem in this case too. So this place is going to be 35 minus r squared minus r squared is equal to 25 squared. Take note, please. This is the right angle here. So this place will be bigger than this two. So we have 35 minus r squared this side minus this side is going to give this. Now let's use the knowledge of difference of two squares. So we have. Now, I want to reiterate this. You understand how I got this place? This one and this one equals to 37. So that's how I got this place. So 12 and this. Now let's go on. So using difference of two squares, I can say 35 minus r plus r into 35 minus r is equal to 35 squared. So here I have 35. And this place I have 35 minus 12 is equal to 25 squared. Now, let's do something else. I can now say that 35 minus 2r is equal to 25 squared over 35. So I can now say that 2r is equal to 35 minus 25 squared over 35. So I can now say that 2r is equal to 35 squared minus 25 squared over 35. So r will be equal to 35 plus 25 into 35 minus 25 over 2 times 35. So you can see, very simple. This is 10, this is 70, and this is 60. So I'm going to have it to be 60 over 7. 60 over R is RA. RA is equal to 60 over 7 centimeters. That is RA. Now to find RB will be easier now. Now to find RB, I just use knowledge of ratio because we have similar triangles now. Let's look at the similar triangles we have. We have this and we have this. For the height, when we are talking about RA, we have 35 centimeters. Now for HB, it will be 35 centimeters minus 2 times RA, which is 60 over 7. That is this place from 35. And let's see what that will give us. So you can see from this place to this place is going to be 125 over 7 centimeters. Now, since we have gotten the ratio, the ball that will be squeezed in this place, the ratio of this radius of this bigger ball to this side will be equal to the ratio of this radius to this side. So let's take it like that. So HRB over HB will be equal to RB over HA. And you see HA is this height from this place down here. Now let's work it out. We have found HB to be 125 over 7, HA to be 35. So RB will be equal to RE over HA times HB. Let's work it out. Okay, now we have gotten the ratio. Using ratio, the RB over HB is equal to RA over HA. And what's our HA? 35. Our HB was 125 divided by 7. Our RA, we have gotten that one to be 60 over 7. And so RB at the end of this, RA over HA times HB. And then these figures are substituted in 60 over 7 times 125 over 7 divided by 35. And this is our RB. So this is the radius of the smaller sphere. 1500 over 343 centimeters RB. So we have gotten A and B. Now let's look for get the volume of the spheres. Now see, volume of spheres. Sphere A will be equal to 4 over 3 pi 60 over 7. Because formula for volume of the sphere is equal to pi 4 over 3, sorry, 4 over 3 pi r cubed. Here r is the radius. So in this instance, our radius is 60 over 7 for RA, and we get that to be 4 over 3 times 60 cubed over 7 cubed pi cm cubed. So volume of square A is 864,000 over 1029 pi centimeter cubed. Now let's find the volume for square B. We equal to 4 over 3 times 1500 over 343 pi. Let me use the calculator. Now volume of square A is 864,000 over 1029 pi centimeter cube, which is equal to 839.65 pi centimeter cube. Please don't forget the pi. For the square B, 4 over 3 times 150 over 343 cube pi. And at the end, that gives me 111.51 pi centimeter cube. I think we have answered C part. So the D part says the ratio of the volume of remaining space to volume of the cone. How do we get the volume of the remaining space? We subtract the sum of the volume of the sphere from the total volume of the cone. That is the volume of the remaining space. We will now use that one to divide the actual volume of the cone. So let me do it straight. So that is going to be volume of empty space to volume of cone. And what do I do that? It's going to be volume of cone minus volume of sphere A plus volume of sphere E divided by volume of cone. And that will be equal to, what is the volume of cone? 16800 pi minus 839.655.515. So 1680 pi. So that's what you are going to have. So 1680 pi. Let's work it out. So you are going to have 1680 minus 951.2 pi divided by 1680 pi. So you are going to have something like this. So this is now going to give us 728.84 divided by 1680. So for my calculator, this is going to be 0.4338. So that is, we are going to have it like this. Ratio 0.4338 to 1. So let's see. So by the time you look at it, it's going to be like 1 to 2.31. And that's going to be approximately, it's going to be approximately ratio 10 to 23. So it's been fun, you can see, very easy to handle, but just need to, recall some techniques. I told you there is another way of getting the radius there, and from there you can use the ratio to get the radius of the smaller sphere. So let's just quickly review that. So another way of getting the radius is this. We have gotten this one to be 35. And we know that this base is 37. This base is 12. Now, this is the radius. We know that from this base to this base is 12, to this base is 12. So, the angle here, let's call this base theta, and this base theta. So, now, I cannot say sine 2 theta is going to be equal to 35 over 37. Sine 2 theta is 35 over 37. Since I know this one, so now if I cannot find sine theta, you can use your formula to get sine theta, or you can use the calculator to get sine theta. So let's find what 2 theta is. So you can see. So theta is 35, that is this theta. Now this is R, this is R. So R over 12 will be equal to tan 35.54. So R is equal to 12 tan 35.54. So let's do that. That is equal to 8.5714 centimeter. Now, if you compare it with the previous results, let's see. 16 divided by 7. That's also equal to 8.5714. You can see. So either way you can use to get the radius